In this video, I'm going to be showing you how to solve limits using L'Hopital's rule, or what a lot of students like to call it L'Hospital's rule, if you have heard about it, because the French name is harder to pronounce, I guess. But basically, L'Hopital's rule states that if you have a limit approaching some point A of a function over a function, and when you plug in A into both of these functions, you get some indeterminate form, like 0 over 0, or infinity over infinity, right? And in doing so, you can actually solve for the limit. You can actually solve for the limit by taking the derivative of your function over the derivative of your other function. Individually, don't use quotient rule. You just take the derivatives of the function of the two functions, and then you will get some answer, some determinate answer eventually. You can, and sometimes L'Hopital's rule could be multiple. You could do it multiple times, okay? You can apply L'Hopital's rule 3 times, 2 times even. But I'll show you the right notation especially for how to prove that you can use L'Hopital's rule, because AP Calculus is especially specific about how you do the work to show that you can apply L'Hopital's rule. You have to prove that you can apply L'Hopital's rule first by showing these two indeterminate forms. Well, this first problem is the very common, oh so common, sine of x over x trig identity, or trig limit identity. Well, we already know that this is equal to 1, right? It's a trig limit identity, but we can solve for this using L'Hopital's rule. So if we plug in 0 into sine, so if we just directly plug in the limit using that, the limit substitution techniques, we get sine of 0 over 0. And sine of 0 is 0, and 0 is just 0. Now, here's the thing. You don't write it like that. In order to show that you can use L'Hopital's rule, you must write the limits individually for both the functions, top to bottom. So as x approaches 0, this looks like a bad x, but you have to write it like this. You separate the two functions into two limits, and when you plug in 0 into sine of x, you get 0. When you plug in 0 into x, you get 0. And this is how you show you can use L'Hopital's rule, especially for AP Calculus. I don't know how college Calc 1 classes do this, but this right here is specifically how you do it for AP Calculus. They will mark your problem wrong if you write down 0 over 0. So make sure not to write 0 over 0. Separate the two functions on either on opposite sides of your fraction in order to show that you have some 0 and 0 or infinity and infinity. Now here's the thing. If you get a 0 in the denominator, but you don't get a 0 in the numerator for L'Hopital's rule, then you can't apply it, right? You need to get some indeterminate form, 0 over 0 or infinity over infinity. All right, and remember, you just need to take the derivative of both functions on the top and the bottom. Don't use quotient rule. Derivative of sine is cosine of x over the derivative of x, which is just 1. So you get the limit as x approaches 0 for cosine of x. That's just cosine of 0. And cosine of 0 is equal to 1, which is your trig limit identity's answer. So again, we have some indeterminate form. If we separate the two functions into two different limits, so as the limit as x approaches infinity for the numerator function ln of x and the denominator function x, you get ln of infinity is infinity, and well, as x approaches infinity for x, it's just infinity. So we can use L'Hopital's rule. So as the limit approaches infinity for, well, the derivative of ln of x is 1 over x, and the derivative of x is just 1. So you basically just get, as the limit of x approaches infinity for 1 over x. And we know this is just 0. As the denominator reaches infinity, your numerator is still some non-infinitesimal number, you get 0. Let's go ahead and solve this. Remember, first things first, you need to see if you can use L'Hopital's rule by writing down your limits. So as the limit as e to the x approaches 1, as the limit as x approaches 0. Okay, well, I said e to the x approaches 1. That was wrong. You guys know what I meant. But as x approaches 0 for e to the x minus 1, you get 1 minus 1. Right? E to the power of 0 is just 1, which is just 0. Alright, we have a 0 in the numerator. Now we just need to prove a 0 in the denominator, but that's already just 0. So now we can take the derivative. Well, as the limit as x approaches 0 for the derivative of the upper function. Well, the derivative of e to the x is just e to the x, and the derivative of negative 1 is 0. So we can keep that out. The derivative of x is 1. So basically, this entire function boils down to e to the x. Limit as x approaches 0 for e to the x. If you plug in 0 into e to x, well, 0 into any exponential function is just 1. So your answer is 1 in this case. So for this problem, you need to use L'Hopital's rule twice. But in this case, this is, it's an asymptotal function. You have a horizontal asymptote. You can use the horizontal asymptote method. If you do that, then you just get x squared. You only worry about the largest powers. So you get x squared over 5x squared, which is equal to 1 over 5. So we can use this to check our answer later. 1 over 5 is the answer using the horizontal asymptote method. But we can use L'Hopital's rule for this. So first things first, we need to prove that we can use L'Hopital's rule by setting the limits of the denominator and numerator functions, finding the limits of them individually. So you get x squared plus 3x, 5x squared minus x plus 1. Well, if you plug in infinity into any of these, you still get infinity. So this can work with L'Hopital's rule. So let's find the derivative of both functions, top and bottom. The derivative of x squared plus 3x is 2x plus 3, and the derivative of 5x squared is 10x minus 1. Alright, let's see if we can use L'Hopital's rule for this again. Well, if you plug in infinity into here, you still get 2 times infinity, which is infinity, and you still get infinity ending up. So let's go ahead and show this. So as the limit as x approaches infinity for both numerator and denominator functions, you still get infinity. So 10x minus 1, you still get infinity if you approach infinity. So we get, as the limit as x approaches infinity, we can use L'Hopital's rule again, so we find the derivative of both top and bottom. Well, that's 2 over 10. Right, just the coefficients, and use this simplifies into 1 over 5. So, using our previous method to find horizontal asymptotes, we got 1 over 5, and in the end, for L'Hopital's rule, we got 1 over 5 still. This problem has a lot more L'Hopital chains, but this will be the last one for the video. I'm just trying to show you as much as I possibly can about L'Hopital's rule, all the possible combinations, so after this video, you guys are set. But basically, for this one, again, you can use L'Hopital's rule. Let's show you can use it. So we just need to set the limits equal to 0 for both numerator and denominator. You get 0 for 0 cubed, and if you plug in 0 into tangent, you get 1. You get 0 as well, sorry. And 0 minus 0 is just 0. Therefore, we can use L'Hopital's rule in this case. Let's go ahead and find the derivative of this. Numerator and denominator functions. So the derivative of tangent is secant squared of x over 1. And the derivative of the denominator is 3x squared. Let's go see if we can use L'Hopital's rule for this again, because, hint hint, yes you can, because this is a L'Hopital's rule video. But basically, secant squared of x minus 1 and 3x squared. Denominator, still 0. If you plug in 0 into secant squared, well, secant squared is just 1 over cosine squared of x. And if you plug in 0 into cosine, you get 1. Right? So you get 1 over 1. So it's 1 minus 1. 1 minus 1 is equal to not 1. 1 minus 1 is equal to 0. So we can use L'Hopital's rule again. Let's go ahead and use L'Hopital's rule. Well, we need to find the derivative of the upper function. And for this upper function, well, we need to use chain rule and power rule. So it's 2 times secant x. And then the chain rule for secant is secant x tangent x over the derivative of 3x squared, which is just 6x. Okay? Well, let's go ahead and show that we can use L'Hopital's rule again, because 6 as x approaches 0 for 6x, well, that's still 0. So the limit as x approaches 0 for 6x is still equal to 0. And for 2 secant squared tangent x, well, tangent of 0 is still 0. 0 times everything just turns to 0. So we get 0 for 0 again. We get some indeterminate form again. So we could take another derivative. Oh boy. How many do we have to do this time? Alright, basically what I did was just skip all the product rule and algebra and stuff like that. Basically, it's just product rule to find the derivative of your upper function. So, but this is, you likely won't get a problem like this on your L'Hopital exam. Like, you're gonna get something more simple. Like, there's no need to do such tedious product rule stuff like this on your exam. So don't worry about all the steps for this, unless your teacher is evil or something. But basically, now we can plug in 0, right? Your denominator no longer equals 0. So let's try to plug in 0. Well, if we plug in 0 into this term right here, this tangent term, you just get 0. So everything in this term zeroes out, right? So all you get left off with is 2 times secant to the power 4 over x. Well, this term right here, as secant approaches 0, you get the value 1. And 1 to the power of 4 is just 1. So 1 here. So all you really get left off with is 0 plus 1 in these parentheses. 0 plus 1 is just 1. So we get left off with 2 over 6. 2 times 1 is 2. That's where I got the 2 from. But basically 2 over 6 is just 1 over 3. This right here is your final answer after you use L'Hopital's 3 times. But as always, if you have any questions, put it down in the comment section. And if you found this video helpful, consider subscribing and liking the video. Thanks for watching.